All right. Today we'll be looking at some physical quantities that have the same dimension. For some questions, we might ask, we might be given one particular quantity and a list of other quantities, and we are asked to find which of the quantities that have the same with the one in a question. So today I'll be showing us a few of some quantities that have the same dimension or that have the same dimensional analysis. So we'll be starting with the work, energy, and moment. All right, we know that work, starting with this, we know that work is defined as work, force times distance, and the dimension for force is given by MLT minus 2, and dimension for distance is length. So if we combine this, we are going to have MLT minus 2 L squared T minus 2. And if we do that for energy and work have the same units. So you can start by saying energy is something as or we can say power times time. Power times time. And we know that power is work over time. So work over time. So power is work over time. So work over time times time again. Can cancel. So in that case, energy is equivalent to the dimension for work, which is M L squared T minus 2. All right, for moment of a force is the product of that force times perpendicular distance from the point of action. So it shows that moment is equivalent to force times distance, and of course its dimension will be as the same as that of work. Now let's go to second set, which is pressure, stress, and Young modulus. The pressure on a surface is given by pressure P equals force, because pressure is a force per unit area, so pressure equals to force over area. The dimension for force has been given by M L T minus 2, and that of area is L squared. This will automatically give us M L1 T minus 2 times L raised upon minus 2. For this will give us M 1 minus 2 is minus 1, so L minus 1 T minus 2. Alright, now if we do that for stress sigma is given as force or load per surface area. So we can see that the dimension for stress is obviously that for pressure, and of course both of the quantities have SI units of Newton per meter squared. Now the next is Young modulus. Now Young modulus E is given as given as a stress sigma over strain epsilon. The dimension for stress is already given as that of pressure, so this is equivalent to dimension for stress, sorry, for pressure, which is m L minus 1 T minus 2. Now the dimension for strain is 1. I will show that in our next video. So that's also 1 is dimension for this. So automatically the dimension for your modulus is the same thing as that of pressure and stress. Now the next one we go now is impulse and momentum. For impulse and momentum. So impulse of a force is given by the product of that force times the time that force acts. So impulse is equal to force times time. And the dimension for force has been established as m Lt minus 2. So times another time now, T raised to the power 1. So combining, we're going to have m Lt minus 2 plus 1 will give us minus 1. That's impulse. Now let's go to momentum. For momentum of a body, m, or you can use P, is given by the mass of that body multiplied by its speed or velocity. So momentum m is equal to mass times velocity. And the dimension for mass is capital M. For that of velocity is Lt minus 1. Automatically I'm going to have it to be what? Mt raised to the power minus 1. So we can see now that the dimension for momentum is something like the dimension for impulse. So lastly, we look at acceleration and gravitational field intensity. Now, acceleration of a body is given by acceleration A is equals to change in velocity all over time, which is equivalent to the dimension for velocity is given as L T raised to the power minus 1. So the dimension for time is T. So this will automatically give us Lt minus 1 times T raised to the power minus 1. Combining, we have it to be Lt minus 1 minus 1 equals 2. Now lastly, we go to gravitational field intensity. Gravitational field intensity is given as intensity I equals to the force per unit mass, force per mass. So F over mass, force over mass. So the dimension for force is given as Lt minus 2. So divided by, so the dimension for mass is m. So once m cancels m, you are left with Lt minus 2, as we see in acceleration. Alright, see you in our next video. Thank you.